pantheon of human technology, there is one machine that sits alone at the top. It is the crown jewel of military engineering. It is beautiful, terrifying, and almost impossibly complex. It is the nuclear-powered aircraft carrier. If we look back, a fact emerges. In fifth-generation fighter jets, the U.S. leads the world by maybe 30 years. But in aircraft carriers, specifically nuclear carriers, the lead is 50, maybe 60 years. It's not just a lead, it's a monopoly. Look at the ocean today. There are 11.5 nuclear carriers in service. 11 of them fly the Stars and Stripes. The half is the French Charles de Gaulle, a ship that tried to copy the American dream and turned into a logistical nightmare. Why? Why in a world where nuclear technology is 80 years old? Is this specific ship the hardest thing on Earth to build? Why did the Soviet Union fail? Why did France stumble? First, let's kill a myth. A nuclear carrier isn't just a big boat with a reactor. It is the only true blue water fortress. Owning one means your fleet has infinite range. It means strategic dignity. It means you can park a piece of sovereign territory off anyone's coast and say, "We are here to stay." But for 99% of nations, this is a hallucination. Building a carrier isn't about blueprints. It's about national destiny, a fancy way of saying your total industrial capacity. Let's start with the steel. You can't just melt down old cars. You need HY 100 high-strength steel. This metal has to withstand thousands of tons of ocean pressure. It has to survive a 30-ton fighter jet slamming onto the deck at 150 miles per hour, thousands of times, without bending a millimeter. Even more critically, welding this type of steel requiring extremely skilled welders and an extremely demanding temperature-controlled environment. The number of countries in the world capable of producing this type of steel can be counted on one hand, and that's just the shell. The nightmare is the heart. A naval reactor is not a land reactor. A power plant on land sits still. A carrier reactor has to power a small city, fit inside a steel can, and survive 50-foot waves, nearby torpedo explosions, and violent combat maneuvers without leaking a single millisievert of radiation. It has to be flawless. One microscopic crack in the pressure vessel under deep ocean pressure? That's not a leak. That's Chernobyl at sea. This is why, when the director of the Soviet Black Sea shipyard was asked what he needed to finish the carrier Variag, he didn't ask for money. He said, "I need the Soviet State Planning Committee, the Ministry of Defense, and the party's Central Committee. I need a great nation." He wasn't being poetic. He was being literal. Without a continental-scale industrial base, you cannot build this ship. What happens if you try to build one without that industrial base? You bleed. Look at the Soviet Union. They built amazing nuclear submarines. They built the Typhoon-class giants. They had the tech. But putting it on a carrier? They failed. The Ulyanovsk was their dream, an 80,000-ton nuclear supercarrier. It was 45% complete when the Soviet Union collapsed. The hull was cut up for scrap on the slipway. It was a monument to industrial overreach. Without a thriving economy to feed the thousands of subcontractors making one-off parts, the project devoured the state budget until there was no state left. Then there is France. They have the pride. They wanted the status. So they built the Charles de Gaulle. But they didn't have the budget to design a custom carrier reactor. So they did something innovative. They took the K-15 reactor from their ballistic missile submarine and bolted it into the carrier. That is an industrial joke. You are using a heart design for a 10,000-ton sub to push a 40,000-ton carrier. The result? The ship is slow, painfully slow, 25 knots. It can't even outrun some frigates. It spends half its life in maintenance. At one point, the propellers vibrated so badly they had to be replaced with old surplus props from conventional ships. And the best part? During sea trials, they realized the deck was too short. American E-2 Hawkeye planes couldn't land safely. They had to cut the ship open and extend the deck by 4 meters. The Charles de Gaulle is a capable ship when it works. But it stands as a warning. There are no shortcuts in nuclear engineering. So why did the US succeed? Because they were crazy enough to try it in the 1960s and rich enough to fail until they got it right. Phase 1. The brute force era. The USS Enterprise. The first one. The engineers didn't have powerful reactors yet. So what did they do? They stuffed 8 reactors into one ship. 8! It was a maintenance nightmare. It was complex. It was expensive. But it worked. It proved the concept. Phase 2, the gold standard. The Nimitz class. They learned. They built the A4W reactor. It produces 140,000 horsepower. Instead of 8 reactors, you only needed 2. This became the standard for 50 years. Reliable, powerful, unstoppable. Phase 3, the future. The Ford class. While the rest of the world is still trying to figure out steam boilers, the U.S. moved to the A1B reactor. It's automated. It generates 3 times the electricity, powering electromagnetic catapults and future lasers. This is a gap. The U.S. didn't just build a ship. They built a 60-year learning curve. They made the mistakes, paid the trillions, and built the supply chains that no other nation can replicate overnight. But why bother? Conventional gas turbines are great now. The British Queen Elizabeth class uses them. Why suffer the nuclear headache? The infinite sprint. A conventional carrier has a fuel tank. If it runs at top speed, 30+ knots, to get to a war zone, it burns fuel exponentially. It has to slow down to meet a tanker, making it vulnerable. A nuclear carrier? It can run at 30 knots forever. It can sprint 5,000 miles to a crisis zone without pausing. It can outrun storms. It can outrun submarines. And here is the hidden kicker. On a normal ship, half the internal space is fuel for the ship engines. On a nuclear ship, the engines need no fuel storage. So what do you do with that space? You fill it with jet fuel and bombs. A Nimitz carries double the aviation fuel of a conventional carrier. That means it can fight for weeks, launching airstrikes 24/7, while the enemy carrier has to go home to gas up. It isn't just an engine, it's a logistical cheat code. But every cheat code has a cost. Money. The USS Ford cost $13 billion just to build. That doesn't include the planes, or the destroyers protecting it, or the $400 million nuclear refueling it needs midlife, or the $1 billion to scrap it when it retires. A carrier strike group costs more than the GDP of many nations. It is a financial black hole, and it's dangerous. We forget that these ships are floating bombs. They are packed with jet fuel and explosives, sitting on top of 2 nuclear reactors. In 1969, a rocket exploded on the USS Enterprise flight deck. It blew 5 holes in the armored deck. 28 sailors died. The ship almost burned. If you don't have the damage control training, the safety protocols, and the sheer discipline to handle this tech, you aren't building a weapon. You are building a floating Chernobyl waiting to kill your own sailors. India took 15 years to build a conventional carrier. Russia is struggling to repair one. Try and go nuclear without the training culture is suicidal. So what does this tell us? Nuclear aircraft carriers are the ultimate symbol of inequality. They divide the world into 2 classes, the superpower and everyone else. China is building fast. They have the Type 003 Fujian, but it's conventional. Rumors say Type 004 will be nuclear. Maybe, but building one reactor in a lab is different from operating a fleet of them at sea for 50 years. The history of the nuclear carrier is a history of national rise and fall. It broke the Soviet economy. It embarrassed the French. It proves that you can have money and you can have ambition, but you cannot buy time. The U.S. bought its lead with 60 years of trial and error. Until another nation can build a safe, reliable, powerful nuclear carrier and operate it globally, the U.S. Navy remains the only true blue water hegemon. The rest are just visitors in America's ocean. What do you think? Will China break the monopoly in the next decade? Is nuclear power worth the cost, or should navies stick to conventional ships like the British? Let me know your thoughts in the comments.